360DigiTMG. So today we are going to explore the one of the project which we worked on. This is related to MILTRANS. So what is all about? We'll see. So first of all, once again, welcome to the session. So this is the project title. We worked on this one of the leading client in India. This is all about context-aware AI translation engine for military standard operating procedures. So means all about Agniveer, right? Agniveers, Indian Defense. We have Navy, right? Navy, Army, as well as military. Agniveer program. The Indian government recently come up with one program, which is Agniveer training. It's all about 4 years. So the training phase includes 32 weeks. So all the entire the 32 weeks, including the training, theoretical, practicals, and the few of the protocols which the soldiers should follow throughout the training. So the client, one of the leading defense training institution in India. So the problem is what the client exactly facing. The training program, like the people who are coming from the training from different regions, right? So the major issue is the language. Okay, the standard operating procedures are in Hindi, right? Most of the standard operating procedures in Hindi. So it will take to understand all those region people. So it will take too much time. The duration of the training period is little bit increasing, and also there is a miscommunication between the trainees and trainer. So our Miltron product will help you to the reduce the gap between the trainees and trainer, right? So our objective minimize the cost associated with the developing the maintain translation infrastructure. Means our product should be transferred, right? The training should be within the timeline. What are the 30 weeks of the deadline? So should be completed means that soldiers should understand the entire the training. Okay. So constraints here maximize the clarity and accuracy also matter. Our product should give the at least 90 plus accuracy, and also we are basically looking to the regional language like Telugu, Hindi to Telugu, as well as Kannada, Tamil. These South Indian languages we mostly focusing on this project. So business success criteria here, deliver SOPs, standard operating procedures, and training documents. A negative language means that regional languages ensure that 95% of trainees should confident after completing the course, whatever the training period, 90%, 95% of the trainees should be confident throughout the whatever the content they learn. So machine learning success criteria. These are some benchmarks we set for this project. The accuracy of the model at least 98 means greater than 98% translation of. The economic success criteria reduce the training program delays, like the extension within the 31 weeks only the training should come. So by adopting this our product reduce to 40% of the training period. So these are the some benchmarks initially set these benchmarks. So I will walk you through architecture diagram This is the architecture diagram. Actually, we collect the data from different data sources, from PDF documents, and also some communities. Also, we have taken Hugging Face a few of the communities related to defense related jargons, and also Wikipedia documents. So we extract the data from different websites related to defense. So for that we use Selenium web scraping tools, Selenium and Beautiful Soup. Okay, a few of the packages used for this extraction, and also we SOPs. We also focus on the images. So images also we extract the data from images. We use Tesseract, OCR, and Paddle OCR. Few of the techniques also use. So also all the data source we integrated into the S3 S3 bucket. Store the data, color the data from all the data sources and store in the S3 bucket. From there, after the processing, we use the unstructured data. Yeah, basically this is transcript, right? So what are the transcript we have? Unstructured means text data. So we use MongoDB for this storing and the processing and all. So and also here you can see this entire flow of the diagram. See here you can understand the business understanding, then different data sources, text, images, PDFs, and few of the communities, and transform, extract, transform, and load. So ETL pipeline to the data flow. So then I've done some few pre-processing. There is an inconsistency in the some um, documents. Okay, we did some pre-processing steps here. I will walk you through. So then what are the clean data is stored in MongoDB. Later we go for model building. We have tried different models, and from this we select the best model based on the evaluation metrics. So I will go through them in detail. Here you can see in detail data source layer, web scraping, here PDFs, Hugging Face datasets, SOPs, and the pipeline includes web scraping, right? You can see here valid data pre-processing and text cleaning, normalization, and tokenization. Everything's done as part of this one. And the whatever the data is here, the data source storage layer, S3 bucket for this raw data. Then the clean data should be stored in the all the integrated from all the different sources. We combine the data into the MongoDB. This is the our actual database. And also we try with vector DB. Vector DB for this semantic source, right? For RAG based applications, we try traditional way as well as LLM based approach. So these are the few models: MT5, IndicBot, and GPT models. Also we tried based on the blue score. Finalize the model and deploy the Streamlit application. This is a high level architecture. So we'll walk you through. Data sources, here you can see the input is Hindi only. So we collect the data Hindi only input data. So there are some challenges in this project because of very limited data is available, and so that to mitigate that, we wherever we um, feel there is a miss. So we also generate the synthetic data. Okay, we use synthetic data also. We use few of the packages, and also LLM models. We generate some synthetic data. to mitigate that issue. Here you can see data pre-processing. So extract the data from images. There is a lot of noise, and also we tried tesseract catalog here. So this image extraction. So our intention is to Hindi to regional languages, Telugu, Hindi, Tamil, and Bengali. Initially, we go for the South Indian language. So later we are going to expand this into the multiple other languages also. Text cleaning here, normalization. There is some duplicates also. We remove some duplicate content and some special characters. We remove this as part of reprocessing. So then the text that into obviously the model will not understand the text directly, right? It's converted into tokens. It's all about internally it's happening this tokenization and a different we have different methods tokenization methods, sentence, word, character, but here a sentence because our context is translated as SOPs, right? So it's to understand the content, overall content. And also we have done some augmentation also, means and generated. So model building, coming to this, once we done with the cleaning part, we pushed into the MongoDB database. From there, we tried different models. The problem is Google Translator. We may question some questions. Why we have what Google Translate? Right? So Google Translate not understand the context, right? The military context. Our main goal is to specific to the military defense related stuff, not other context. Because if there is any miscommunication, there is a problem, right? So the Google Translate is some benchmarks so that the model fail to identify domain specific terms. So our product is mainly focusing on the domain. So we also tried with the sequence to sequence model, a basic RNN. So there is a problem. There is a long dependency issues. Will not capture the basic model. So then we tried the transformer based model, MBOT and trans. These are the already trained on this multilingual languages, Indian languages. So we choose this, we fine tune these models, and ultimately we also try track based models. So where we use the vector data as a similarity search, and also LLMs. The data LLM communicate with the database based on the user questions. The LLM will get the data from the RAG. So the combining a combination of these contexts as well as the similarities as the final output uh, due to the user and user. So we also tried this hybrid approach also. So ultimately we got these metrics. Google Translate just in 0.59 accuracy and the basic RNN 0.71 and MBOT index. Out of this, the LLM based model got around 91% accuracy. So, and these are the future scope of this project. We are going to implement a few more languages and also continuous fine tuning on feedbacks. So based on the feedback, we will implement further more actions. And because of the LLMs going to take more cost. Okay. So that's all, guys. Okay. Thank you for joining the session. So we'll connect further in future. We will connect another project.